A typical high-voltage distribution network is designed to deliver power to customers. It consists of multiple feeders connected to a substation. A feeder typically powers a residential area or an industrial facility. Power lines coming in contact with vegetation may have fatal consequences. During extreme weather conditions, such as extreme dry landscape, temperature and winds, a faulty power line will act like a fire starter. The criteria for starting a fire is related to the level of earth fault current and time. A high-voltage network is always equipped with some kind of protection for failed components or power lines. However, the detection of this type of failure in the network, known as a high-impedance earth fault, is normally not possible with conventional protection systems. Conventional protection systems cannot detect such low earth fault current and can therefore not disconnect the faulty power line. Some conventional protection systems cannot even distinguish between a normal load and an earth fault. If a person detects the faulty power line before the electrical protection system itself, it may be too late since the fire is already started. There is a way to avoid the fatal consequences of not detecting the faulty power line. By installing a GFN, ground fault neutralizer system in the substation, a catastrophic fire can be avoided. The GFN can detect and locate any earth fault type, including the most dangerous high-impedance earth faults. The GFN acts super fast utilizing power electronics, and the earth fault current is gone even faster than a breaker possibly could have tripped the fault, if the fault was detected and located correctly, which is unlikely the case. The GFN utilizes a smart differential earth fault locating algorithm, where minimal delta current is injected into the earth fault for the purpose of being able to locate the earth fault. The GFN protects the complete network from one location, the substation. After detection of the earth fault, the GFN neutralizes the earth fault current by injecting current in opposite direction to the earth fault current, resulting in a current collision at the fault site. The fault location becomes safe, even for humans to touch without the risk to die. The faulty power line is not required to immediately be disconnected. While the GFN is on and compensating for the earth fault, the exact earth fault location can be located or the faulty feeder. Or even better, the faulty section can be disconnected in a controlled manner. The GFN can be further improved by installing Swedish neutral FPIs along the lines on existing ACRs or using other CTs. The Swedish neutral FPIs utilizes the same smart differential earth fault locating algorithm as the GFN system and therefore have far better performance and robustness compared to our best competitors.